In this question, it is given that a small sphere of radius r falls from rest in a viscous liquid. As a result, its heat is produced due to the viscous force. The rate of production of heat when the sphere attains its terminal velocity is proportional to. So over here, heat is produced due to work done by the value of frictional force or the resistance force. So you can write heat is equal to work done by the viscous force. And we know that work done is equal to nothing but force into displacement. And over here, there is Rm is to find out the value of rate of production of heat. So heat energy per unit time or work done per unit time, which is nothing but the value of power. And we know how to find out the value of instantaneous power, that is equal to force dot velocity F dot V. So we can write the relation between them, that is the value of viscous force is nothing but 6 pi eta RV, and V over here is representing the terminal velocity. So we can write this terminal velocity is depends upon the value of 2 divided by 9 into r square into density of object minus density of liquid into g divided by coefficient of viscosity eta. So we can write this P is nothing but F into V, and this F is directly proportional to this force. You can observe that it's directly proportional to r and velocity, and this velocity is directly proportional to r square. So we can write this P is directly proportional to this F, which is directly proportional to r into V into the value of V. So we can write this as r into V square, and this is r into the value of V is directly proportional to r square. So this V square is directly proportional to r raised to 4. So we can write this P is directly proportional to r raised to 5.